Okay, so that's all for today. So then tomorrow we will see the PyODBC connections. So how actually a Python program can connect to SQL Server database. So we'll see that tomorrow, and then we'll close the SQL by tomorrow. Okay, so that's the plan. So yesterday I was not able to connect because of my project meeting. So today we will try to close most of the functions, analytics functions. Okay, so here if you see, uh, in our last session we have discussed detailed things about row number. So today we will see about rank and dense rank. Okay, so just give me a minute, guys. So I'm getting some messages. Just give me a minute. Guys, just 2 minutes. I'm getting some important messages related to project. Okay, fine. So today let's see the rank and dense rank functions. So let me go to this VB. Execute this. Yeah. So this is my table. I have employee table, employee ID, and I have department and salaries, right? So here, if you see, we have seen the row number, which will give the sequence number for the window functions that you have declared. In the over clause, whatever you have declared, according to that window, you will get the row number functionality. Okay. So now we will see the rank function. So how we will apply the rank function. So select star, comma, rank over, okay, over. I'm just ordering by salary, order by salary as rank from employee. Okay. So here if you see, it ordered your salary, it ordered your salary and it has given a rank to it. Okay, it has given a rank to it. But when you see, if you have a same salary, it has given the same rank. And immediately after it found the different salary, it skipped the consecutive rank. Try to understand, guys. So here you have 62,000, 62,000, and your rank function, what it has given 11, 11. Okay, so based on the salary, it started giving the rank, okay, starting from the 1, and as and when it reaches the same salary, it has given the same rank. It's okay, it has given the same rank, but immediately if you see, it founds the next salary, but it has to start with 12, right? But it skipped 12, and it has given 13. And similarly, if you see here 14, 14, and then immediately it has to give 15, right? But it has given 16, right? So the rank function will skip the immediate rank. Okay, we'll skip the immediate rank. So it will assign the same rank if you found if it founds the same uh, salary, and then immediately it will skip the consecutive rank. Okay, so it depends on the window function that you define, right? So for example, if you specify partition also, if you specify partition also, it will check internal to that partition. It will check internal to that partition. Okay. So, but when you see partition wise, you don't have any concerns with the rank, because in the single partition, we don't have any same duplicated salary. Okay. So you need to understand the functionality very clearly. So here, if you see, if you don't specify any window or any partition, okay, then the behavior is very clear, right? So you are now only ordering by salary, but you are not specifying any partition on department. So what it is doing, for the same salary, it is giving same rank, but immediate to that same salary, it is skipping the consecutive rank. It is skipping the consecutive rank. But in the same partition, let us take an example. I have given partition by department, order by salary. So when I execute it, let us take an example. In the same department, if you have duplicate salary, then your rank function will assign the same rank. Immediate to the duplicate salary, the consecutive rank will be skipped. Guys, are you with me? Are we clear? Are we
Yeah, I
clear
think
with?
there is one record in IT department.
Okay, in IT, where is it?
Yeah, 7 in IT 7.
Yeah, yeah, 7. See here. Okay. So here, if you see, yes, we have one record which is 68,000, same salary in the IT department. So because you partitioned on IT or department, so you got the same rank, but the consecutive one got skipped. It will give 9, because it will count 7, 8 internally, and then it will give 9. But rank wise, it will give the same rank because it has the same salary. Okay. So this is rank function. Now let us see dense rank function, right? So dense underscore rank. So when you do this dense rank, you don't see this kind of behavior, the skipping of immediate consecutive rank. Okay, so you don't see this kind of behavior. See here, in your IT department, when it found the same salary, it has given same rank, but it started with the immediate consecutive rank. Okay, guys, are we clear? What is row number is doing, what is rank is doing, what is dense rank is doing? Row number, it doesn't matter whether it is duplicate or not a duplicate. It will go and assign the consecutive sequence number, that's it. Rank will assign the duplicate rank or same rank for the same salary, and then immediately it will start skipping the consecutive rank. But the dense rank won't do that. Dense rank will give you proper ranking. If it is the same salary, it will give the same rank, but immediate to that you have the actual consecutive rank. That is what dense rank function will do. Okay, guys, are you with me? Are you able to understand?
Yeah, clear.
Yes. Yeah, clear.
Okay, so now let us understand lead and lag functions. Okay, so these two are also important when you want to compare your records with the previous record. Okay, so the functionality is very clear in real time projects when you use dense rank and rank, or else for that matter the row number also, right? When you want to eliminate the duplicates for a specific partition depending on the timestamp, or when you want to extract the specific position of the record, right? So let us take an example. I need the second transaction record, or I need third transaction record with respect to the timestamp. Okay, then in that case you use this row number, rank, dense rank functions. Okay, so we hardly use rank function. Most of the times we prefer to use dense rank function because it will give the proper ranking. Okay, so now this lead and lag functions are always used to compare the previous records. Okay, so what do I mean by that? Let us see. Select star comma lead over order by salary, partition by department, order by salary. Okay, as from. Okay, so I think it is doesn't need any kind of. Just 1 minute, guys. Let me.
Hi.
Yeah,
After salary 1 comma 0, we need to over by order by.
yeah, correct, correct. That is what even the syntax is something. A salary of one over of,
Order by.
yeah, ordered by salary. Okay, yeah. So yeah. So here, if you see, the lead function will make your last record as null. Okay, and it will shift your record to the upper level. So first we will go for lag so that you will understand. Okay, so here if you see the lag function, if you want to compare your salary, or else if you want to compare your salary of the employee with the previous salary, let us take an example. For a typical same employee, if you want to compare the salaries, the previous salary, if you want to compare the current salary with the previous salary, let us take an example. This is your current salary and this is your previous salary. So if you want to identify the difference, right, if you want to check the difference of the salary, the current versus previous. So in that case, your lead function will generate a new column, keeping the first record as null. Okay, keeping the first record as null. So similarly, the lag functions, the lag function will give you the first record as null. Lead function will give you the last record as null. So that is the difference. So when you really want to compare the current versus previous, or previous versus current, depending on your requirement, you can actually use this lead and lag functions. If you want to compare based on a timestamp, or based on the employee ID, if you want to compare for a specific partition also, so you can always specify the partition by clause here. Okay, so for a specific partition also, if you want to compare, you can actually do that. Okay, so this is something that you need to understand, the lead and lag. So we use these functions in real time when you want to compare in a specific partition. If you want to compare, for example, for the same ID, okay, for the same ID, if we want to compare the previous record versus the current record, or if you want to get the difference between the timestamps, let us take an example. You have an employee login system. Okay, now every employee is logging in and every employee is logging out. Okay, so now your data is populated in such a way that employee ID, timestamp, and activity. Okay, so employee ID, timestamp, and activity. So every employee can log in and log out multiple times in a typical day. Correct. So we go to office, we swipe in, and then we do work, and then again we log out and we'll go out and we'll have lunch, and again we'll come back and we'll log in, and then we'll work for some time, again we'll log out, we'll go for a coffee break, and then we'll log in again. So we do a lot of activities, right, in the office. So let us take an example. For a typical employee, you got 10 to 15 activities per day. Log in, log out, log in, log out, log in, log out. Okay. So now if you want to identify how many hours that employee got worked, right? So in that case, you may need to compare the time difference for a typical employee, right? So when it is login, difference between login and log out, so how actually you'll use this, lead and lag functions. You'll partition by activity and employee, and then you will take the login versus log out difference, and then you'll try to calculate the sum of it. So that's how you'll utilize these lead versus lag functions. So these are mostly we use when we get a case to compare the current record versus previous record for a specific window. Be very very clear, this lead and lag functions will be utilized when we get a requirement in such a way that if we want to compare the current record versus previous record for a specific given window. It may be partition by, or it may be order by, whatever it is. For a specific given window, if we want to compare the current record versus previous record, then we will try to use this lead and lag functions. Okay, so lead function always keeps the last record as null, and then lag function will keep the first record as null, so that you'll get the next column, and then you can identify the difference. Okay, guys, are you able to understand?
Yes.
Yes.
Okay, so that's about we have seen four analytic functions, guys: row number, rank, dense rank, lead, and lag. So we have seen four analytic functions. So there are extensions to the group by clause, actually roll up and cube. So these functions we don't use much. Uh, I request you to go and explore these two functions, roll up and cube. Okay, roll up and cube. So these are the two functions which are actually extensions to the group by clause. We don't need them actually, because we can achieve whatever they are giving, we can achieve them using group by. Okay, but those are just extensions to the group by clause. Okay, so now let us understand a few tasks. Okay, so I will give you a few tasks in SQL. I
Ankit, before that, want to know one thing. Aren't we use stored procedures?
Yes, we do use stored process. We write stored process. I will explain the stored process part when we are in BigQuery. Okay,
Okay,
so
okay,
in BigQuery we will write stored process and we will execute. So when we were in data warehousing in Google Cloud, we will discuss about stored process part.
okay. Thank you.
Okay, yeah, fine. So this is okay. So fine. So let's discuss about few tasks in SQL. So I want you guys to write the queries for these tasks. Okay, so let us take our tables. Okay, so I have the customers table, I have order details table and orders table. Okay, I have customer ID here. I have in the customers table, I have the customer related details, and in the orders table, I have order ID and customer ID. Okay, and in the products table, I have the product ID, and in the order details table, I have order detail ID, order ID, and product ID, and quantity and price. Okay, so here if you see, I request you to note down the schema for these tables. Okay, this is one data model we have. One is the customers table. Okay, where we have customer ID, first name, last name, and customer related details, registration date, everything. Okay, and the next table is orders table, wherein order ID and customer ID from the customers table, referring as a foreign key. Okay, and then order date. So this customer has ordered something on this date, and the amount is this. Okay, and similarly order details, wherein order detail ID, order ID, product ID, quantity, price. Okay, so and then I have products table. I have product ID, product name, category, price, stock quantity. Okay, so this is my data model. Okay, are you able to note down this schema?
So three tables: order details, orders, and then products, right?
And customers,
Okay, can you
Cust-
expand the customer ones?
yeah. Customer ID, customer details, and the registration date.
Yeah.
Okay, so one customers table, order details table, okay, orders table, products table. Okay, so now the first task is identify top three products. Okay, identify top three products. So meaning, so you need to identify the top three products which are which are most liked by the customers. Okay, so you need to identify the top three products which are actually most favorite to the customers. Okay, so how you will identify, you have a lot of ways to identify based on the category or the count of the quantity, or whatever way you can select. So you can, for every product, you have the quantity, and you can check the quantity. You can take the sum of it, and then you can try to derive the top three products. Okay, so you need to write a SQL query to identify the top three products. Okay, this is the first task, and the second task is write a SQL query to identify top three customers who are purchasing more, or who are spending more to my retail store. Right? So write a SQL query to identify top customers, top three customers, or else top two customers I need. Let us, okay, identify top two customers who are spending more. Identify month wise, okay, who are spending more for that month. Okay, and we should not use top function here. No top function. So we have a top function in SQL Server. We shouldn't be using it. Okay, these are the two tasks, and the third task is, you have the employee table here. If you see, till now we have seen the employee table, right? So wherein we have, this is the employee table. We have first name, last name, birth date, hire date, and department salary. Okay, and the first task related to employee table, so this is actually retail model related queries, and employee. So here, identify the number of years experience in the company for each employee. Okay, so you have hire date with you. Okay, and I need the experience of the employee in the different column. Okay, including months, I need how many years and how many months he completed. Okay, okay, in months. So next task is identify the second highest salary in each department. Identify the employees who are getting the second highest salary in each department. So I need the department wise the second highest salary. Okay. So department wise the second highest salary. So who are earning the second highest in each department. Okay. So similarly, the next task followed by identify the employees who are earning second lowest in each department. Okay. The next task would be identify the employees who are earning more than the average salary of their department. Okay. Guys, 5 SQL queries. One is identifying the top 3 products, identifying month-wise top 2 customers who are spending more, and identify the number of years of experience from the employees table, identify the employees who are getting the second highest salary in each department, identify the employees who are earning the second lowest in each department, identify the employees who are earning more than the average salary of their department. So any questions, guys? Any questions here in the tasks?
No.
Anybody have any questions? Did everybody noted the schema for the retail?
Yeah.
Okay. So that's all I have for today, guys. Let's connect tomorrow. Let's understand how actually everybody is writing SQL queries. And then tomorrow we will see Python ODBC connection, PyODBC connections with SQL Server along with Python. Okay. So we'll try to see the combination of Python and SQL tomorrow. Okay. That's all I have for today. Thank you so much for joining. Yeah.
Thanks.